Hey guys, how you doing? Today in this video, we're going to solve maximum width of binary tree problem. So let's jump into the problem statement. We are given a binary tree, so we have to write a function to get the maximum width of the given binary tree. So we have to calculate the width of the binary tree by measuring the width of one particular level. So one binary tree can have multiple levels. So we need to find width of all the levels and we need to return the maximum of it. Right? So the width of one level is defined as the length between end nodes, that is the leftmost node and the rightmost node. We'll see with an example. So I will add two more nodes. So for example, this is the first level and this is the second level. The width of the first level is 1 and the width of the second level is 2 because there are two nodes. But the width of third level is 4 actually because there is a null node in between, right? This is the leftmost end node and this is the rightmost end node. So we need to count all the nodes including the nulls, all right? The width of level number 3 is 4 and the width of level 4 is 2. All right, so we need to return this width. Okay, hope you got the problem statement. So let's see how do we solve this problem. Let's start to code this. So we need to traverse the binary tree level by level, right? So we can use BFS traversal for that case. So let's start to have a queue. So I'm going to declare a queue with a tree node and its position, all right? So it's a collection of one tree node and its position. That's a tuple. So initially, if the root node is null, then just return 0. All right, there is no width. Let's start to process this queue. Queue.count is greater than 0, and we need to return the max. So let's declare that where mx equal to sum minus 1 initially or 0, let's say. And the queue initially contains the root node and its position as one, right? So we need to dequeue all the nodes in the current level. If we are processing one particular node, and that node will be in one level, and its children will be in the next level. So we can dequeue all the nodes in the current queue, and then we can explore the children and add it to the queue. That'll be the next level, all right? So let's take size while size is greater than 0. Let's dequeue the current node. So where node and its position equal to q dot dequeue. And so we need to explore its children, right? So before that, we need to keep track of the first and last. So maybe we can have a list, or we need just a position, right? We need the first node's position and the last node's position. So let's declare uh, first equal to 0 and last equal to 0. Okay. Once after we dequeue the node and its position, we need to say uh, first equal to the position. All right. So this first variable should be set only once, right? Only for the first time. So let's refer to the value. If the first position is 0, then we can take that position and set it. If we dequeue the next node, we don't need to set the first position again, right? So that'll be set already. And by default, we can follow the remaining position so that it'll be tracked as last. Once we track this, so we can explore its children, all right? So if node dot left is not equal to null, then q dot enqueue. Here, in order to enqueue the node's left child, so we need to calculate its position as well, right? So hope you remember the heap data structure. So the position of the left and right children, we can calculate its index and we can store it in the same array itself, all right? So we can calculate the left index by, so first we can set the left, and the left child index is whatever the current position into 2, right? And if nodes dot right is not equal to null, then q dot nq node dot right and position into 2 plus 1, right? So once we got the positions of the first node and the last node, then we can easily calculate its width, right? So last minus first plus 1 and mx equal to node dot max mx and the answer. So we are returning the max, right? Let's test this. Right, it works. So let's try to submit this. Hope you enjoyed this video. Thanks for watching.